I wanted to talk about the TBS Crossfire Nano Pro RC receivers just a little bit, about their power and their CRSF signal. I did want to speak about. And the first is their power and how I'm using it on the H743 wing. And you can see right here this 4V5 voltage that's developed from USB and the flight battery. Right here is designated as max 500 milliamps. That is exactly how much the Crossfire Nano Pro is supposed to put out in power at its highest power. And you've heard me talk before about the ratings of boards. Let's say the 743 wing is exactly 500 milliamps. You can put a 500 milliamp load on it with no problem whatsoever, but if you put a 501 milliamp load on it, it blows up. This is just theoretical, because all of this is theoretical. We can't tell what load this board will actually take. And as I discussed in a previous one, the board may take technically 700 milliamp load, but they just say 500 milliamps, so they're covered. It just depends on how the company does their tests and rates their equipment. It's all up to them. Personally, I always have mine do about 20 to 25% more than what I put on the documentation. A lot of companies do it that way. Some companies will take a flight controller that will only accept a load of 400 milliamps, and because their competition says 500 milliamps, they'll just put 500 milliamps on there when it won't do it. That's the kind of company I don't like. We're not going to get deep into those little discussions because you can never tell what a company's doing. So we're going to push that aside, and we're going to say, in this perfect world we're in right at this moment, this board puts out exactly 501 milliamps, and 501 will blow it up. Well, that means probably I could put that full load of the 500 milliamps of the Nano Pro. Now, let's see if we can go over and look at the Nano Pro specifications, if we can find that anywhere. Because truthfully, if it's going to transmit 500 milliamps of power, well, there's some overhead for some other, there's some overhead for some other things. Input power 8.4 volt, requires firmware 614 or above, because we're actually up to 617 at this point. Doesn't say its power consumption here. Let's see. This is technically the manual for all their Nano processors. I don't know if it's been modified specifically for the Nano Pro or not, because it still says Nano RX at the top. And seeing this revision right here is 2021, I don't think it's been updated. So I don't think I'm going to be able to get this. Yeah, firmware 2.24. Yeah, see, this hasn't been updated. So if I did even have a specifications list down here, which I do not, it doesn't tell me the power consumption. Well, it's on there, a declaration of conformity. No. This should be up to date, but I don't think it will be either. So we don't know. My thoughts are is if this thing puts out 500 milliwatts of transmit power for telemetry. There's some overhead for the rest of the circuitry. It draws 510 milliwatts. Or 520 or 505. I don't know. We just looked for specifications and didn't find it. Let's see what we can find on specifications on this GPS for kicks real quick. Yeah, see, it's got power consumption right here, 50 milliamps. So you know that I'm putting a Crossfire Nano Pro receiver right across these 6 pins. So I can do CRSF on UART 6 and MAVLink on UART 4 and pick up my voltage and ground here. You also have seen today that I'm going to use M9N 5883 GPS module on these 6 pins. And if you did see what I looked at right there quickly, power consumption of that GPS module is 50 milliamps. So in this perfect world we're talking about, if I put my Crossfire RX Pro and it's on its highest possible output power for telemetry, it's already at this 500 and it's running along young, dumb, and happy. No problems. Probably a little warm, like most young are, but happy. But if I connect the GPS module to this 4V5 voltage, boom, I'm at 550 milliamps draw, and I just blew up this board. So that's why in one of the previous videos I told you that I wasn't going to be setting the power on the RX Pro to its max because of this. Now, should I have to use the max on the board with this GPS hooked up here, I'm going to have to unhook this power wire and move it over here to VX on the servo rails where that has 8 amps of power. Or, let's see, what's this, 5 volts? That's the VSW, 5 volts. Yeah, see, the 5 volt power is 2 amps continuous, so it would be fine. I could probably just take that wire from right here and move it up there and just have it connected right here instead of right there. Maybe I should have done that to start with. Or I could have put 2 connectors on that receiver and a 4-pin DuPont connector and a 2-pin DuPont connector, and I could have put it across these 4 pins for CRSF and MAVLink, and then put the 2-pin DuPont connector over these 2 pins, and I would be at 2 amps max and never get in trouble running that 500 milliamp Nano Pro and the GPS on a voltage. And you can see if I'm not running the RC receiver on this 4V5, this 4V5 is fine for the 50 milliamp compass module. Now, if you weren't doing telemetry here, you'd have to think about if you were doing telemetry up here. No, because you'd be running off the 5 volts. You wouldn't have to worry about adding to this 500. So where else is that 4V5 voltage? I don't think it's much of any place else. Nope, it's right here. Oh, look at this. This is different from the original. They put the 4V5 voltage into these connectors, the I2C connector, and also the CAN connector. I've got a CAN GPS around here someplace. I'm going to hook it up to this because On my original H743, I used a CAN GPS module, and it doesn't power up when the until the flight battery is connected. It doesn't power up when the USB is connected. That's why I like using this right here for that, so that when the 4V5 voltage comes up, it powers up my GPS module. I really wish it didn't power up my receiver because I don't need it at that time. Maybe that's another good reason to move this one wire up right here. Just pull it out of there, put a single pin DuPont connector on it, and put it up here. I may just do that. So these two, this is for I2C, and this is the CAN connector on the flight controller. Now they're running 4V5. I'm going to have to go back and look at that, but let's look around real quick. 5 volts. That's the servo rail voltage there. 5 volts there. This is the voltage that is either 5 volts, 9 volts, or 12 volts. I hope you can still pull that up to 12 volts. Yeah. Where is that jumper on this new controller? Wow, there it is. 9 volt rise to 12. And all the other controllers I've been working with, it was over in this area physically. So that's what we have to think about and see in the Dragon Link is 2 watts of telemetry output. 1 watt of telemetry output, twice what the Crossfire module is. I had to take it off of this, and I did put it over here, and 2 of my airplanes. Well, I know the original Mini Talon is that way. Oh, and the original Skyhunter is that way too. I just didn't even put it here. I did put it here to start with until I started hearing people talk about this and looked at it myself and said, oh, yeah, it's going to pull more than 500 milliamps. I don't want to blow up my board. So that's one thing I would like to talk about in the Crossfire Nano Pro receiver. Watch out where you power it. And if you use it on max power, you could blow up the voltage regulator behind this pad. It's not physically behind the pad, but electronically. And I did go back and look at the original 743 wing that I've got in I think it's the Skyhunter. I think the Mini Skyhunter. Anyway, I looked at its layout and stuff, and you can see right here in its CAN bus, CAN connector on it, it's using 5 volts. It's not using that 4V5 voltage like the H743 wing version 2. That's why my GPS doesn't power up when I power up that flight controller from USB, whereas this one's going to. I didn't know that it had 4V5 voltage in the CAN bus, or I would have ordered CAN bus GPSs for both of these flight controllers, because that way I don't have to make up a wiring harness. That was one of the things about Ardu Pilot for years is basically their hardware, all the wiring was pretty much in the hardware. If you needed a certain module came with a 4-inch wiring harness and you needed a 10-inch, you just turned around and ordered a longer one from the same company. It's better if you know what length you need when you order up front, but it can be done in a second ordering. But when I looked at these flight controllers, and outside of our pilot, there's a lot of wiring that needs to be pins on these controllers is a crazy wiring that needs to be done. But it looks like the 743 versions 2 and version 3. I hope this isn't this way on version 3, and on version 2 it's still the 5 volts like the old one. But see, this case you would have a problem of putting a Crossfire RX Pro on these wires, a Compass on these wires, or if you had a Compass that was CAN hooking it to these wires, you're just loading down that 4V5 more and more, and then my intention is to hook the airspeed sensor into this connector without any kind of need for any kind of wiring harness. Like I say, I would have ordered CAN GPS modules if I known this was 4V5 voltage. So that's just a little bit of notes and stuff about power consumption on this 4V5 voltage and the Nano RX Pro. And I'll hit another topic here in a second, but we're going to go ahead and close this one out with a thank you guys.